Next, we're going to take a look at reflections or flipping the graph. So again, as a reminder, if the negative is on the outside, it's a vertical reflection. If it's on the inside, it's a horizontal reflection. So I'm going to start by identifying the parent function. So in this case, we've got the absolute value of x. Because it's just a reflection, that critical point doesn't change. So for absolute value, that's the origin. Domain doesn't change with reflection. So for the absolute value, we've got all real numbers for our domain. The range, however, with a vertical reflection, because it's on the outside, the range, instead of being y is greater than or equal to 0, it flipped vertically, so y is less than or equal to 0. Another thing that you can do if you're having a hard time with domain and range is wait until you've got the graph figured out, and that visual piece might help you figure out the domain and range. So don't feel like you have to identify those before you get the function graphed. Again, I like to plot my parent function values. So for absolute value, it's going to make all of these positive. And then what I do for reflections is I add an additional column. If it's a vertical reflection, I add a column off to the right of the y values, and I make them all negative, because that's what a vertical reflection does, is instead of graphing above the x-axis, you graph below, because it flips it below the x-axis. If it's a horizontal reflection, I add a column off to the left and make all of my x values opposite. Since I don't really have room to make another column, since I put my graph right next to it, I'm just going to go ahead and change all of the signs. So obviously we can't make 0 negative, I'm going to fix that. Change all of the signs on my y values. So now I have the correct direction for my reflection. Starting with my critical point of 0, 0. And I'm going to call each of these 2's, scaling my graph for you. I'm going to go, this first one tells me left 2, and then down 2 after I reflect it. Left 1, down 1. And then because the absolute value is symmetric, and we know the slope is 1, I like plotting a whole bunch of points just to get my line a little bit straighter. We can either reflect it across the line of symmetry, or just use that slope that we know about and graph the function that way. The next parent function is our cubic. Again, when it's just a reflection, that critical point doesn't change. The reflection is multiplying by a negative, and because most of our critical points are 0, 0, multiplying 0 by a negative doesn't change anything. Domain, you can cube anything, so we've got all real numbers. Range, we get all possible values when we cube numbers as well, positives and negatives. Setting up my parent function t-chart, negative 2 cubed is negative 8. Negative 1 cubed is negative 1. Of course, 0 cubed, 1 cubed, and 2 cubed. This time, because the negative is inside grouped with the x, it's a horizontal reflection. So what I'm going to do is make all of my x values opposite. So you can either do, you'll see on my answer key, this is what I do. Off to the side, I write what the reflection is, and then I change all of those x values to be opposite. And those will give us our correct directions. So for my critical point of 0, 0, and again scaling all of these by 2's, I'm going to go, my first set of ordered pairs tells me right 2, now looking at the purple column, right 2, down 8. And then I'm going to go right 1, down 1, left 1, up 1. My final one is left 2, up 8. And the cubic function looks like a snake, I guess. So there's our reflected cubic function.